So today marks a very special day in that we have our first scientist coming to our channel, Dr. Sebastian Olbrich. He was gracious enough to accept our invitation. I attended Dr. Olbrich's talk a couple of weeks ago and was extremely intrigued when he started talking about the usage of EEG data in deep learning, and also where he had reviewed a series of scientific papers, and then he had more specifically identified pitfalls. And I thought it was very interesting, especially for our channel, because we have a lot of people who are either students or interested in cognitive sciences. Some of you guys are interested in BCI, some of you are interested in AI robotics, but nonetheless, EEG related data. And so thank you so much for being here today with us, Dr. Olbrich.
Yeah, you're welcome. It's a pleasure for me to be here.
Thank you. So would you mind just giving us a little bit of an overview about yourself, about your work, and maybe a little bit of a background so we get to know you, please?
Yeah, for sure. So thanks for the invitation, Nilo. It's a pleasure. My name is Sebastian Olbrich. I work as a chief of the Center for Depression and Anxiety and Psychotherapy at the University Clinic in Zurich in Switzerland. I was trained in Germany and Leipzig, and that's close to the place where the EEG was invented in the last century in Jena. So I was trained there as a physician and then changed to Zurich in Switzerland. I work here since like 7 years already. And the EEG has always been accompanying me since my early days being a doctor. And I think the mixture of scientific research and clinical work is what me kept going. And I really like that, combining these technical methods and this fast evolving field of electrophysiology and clinical work. So that's where I am today, and I'm really glad to have the opportunity to share with young scientists and interested people the developments in the field.
Wow, I had no idea that you actually started your career where EEG was invented, because I am very much interested in EEG. So before I ask you my first question, just based on what you just said, because now I'm even more excited, why do you think there is that most of the scientific paper that we have today are mainly geared towards what I call the physical brain, namely neurons, neurotransmitters, the chemistry of it, whereas you always find much less scientific papers when it comes around about EEG, which is the sort of invisible part of the brain, if you will.
Yeah, that's true. I think I discussed that a lot with colleagues that are into EEG research. And I think one main reason is that during the 80s and 90s of the last century, the MRI and the fMRI technique evolved pretty fast. And the kind of visualization you get from these techniques are much more made for our modern brains. You have colorful pictures of brains with blobs and everything and color inside. And this seems more plausible for the viewer. And so I think these techniques, they got funded, people were interested. However, we really have to take in our minds that the EEG is the only non-invasive method that is able to capture the ongoing activity of the neurons and all those cells that produce our thoughts, our consciousness, our cognitive abilities. And I think people neglect that, because if you use, for example, fMRI, you have differences of like 3 seconds between each picture. And if you make an EEG with a sampling rate of 1000 hertz, you have like 1000 pictures in a second. So this comes pretty close to where the neurons work. And I think you're absolutely right. We really have to look into that window of electrophysiology. And the other techniques and modalities, of course, have their reasons for being, but the EEG is underestimated at the moment, definitely.
That is so true. And I'm getting even more excited hearing you talk about it, because most of the scientists I've come in contact with, my own research started at Stanford with fMRI, big fMRI machine, which was fantastic, Dr. Knudsen. But it was as if when I told him, for example, first time I wanted to do my PhD and I said, I want to just do EEG, I always get a like a little bit of a, really, why? It is as if EEG is still not being, I don't know, recognized, if you will, in the field. So I'm very happy to see more. And that's one of the other reasons that I dedicated not only my own research, but also this channel to those who are interested, because the way I think about it, also, if we think about what is information, the information that is being right now transferred from me to you, it is those electricity, their atoms, or even if you want to go to quantum level. And so that's why the field of quantum biology becomes very interested. And to me, EEG is the one who can explain those. Obviously, you have the chemistry and neurotransmitter, but the traveling of the waves of information that goes through EEG. So that's why for me, it's very exciting that we get more on scientists or future scientists who are interested in EEG as well. So thank you so much for sharing that. Now, going back to your paper, would you please give us a little bit of an overview about all these different scientific papers that you first reviewed and the type of EEG data that they use, and what is it about those specific EEG data that you identified that was mainly used within these papers? And also, how were they used? And the reason I'm asking is that our viewers are aspiring, to be either scientists or programmers, etc. And so for them to also understand a little bit from your background and experience as to what is it possible for them to even think about when it comes to EEG data and deep learning.
Yeah. Okay, that's a very long question. I hope to make several points and also try to make it clear for the listeners. So Erika, everybody can follow up. If not, I'm open for questions later on via email or whatsoever. So yes, maybe I get the story a little longer. I dived into deep learning research combining EEG like 5 years ago, just several years after those deep learning networks evolved. And the reason was that there is a high similarity between the EEG and the main tasks deep learning networks were doing at that time. And that was visual classification tasks. If you say, okay, a picture is different from an EEG, however, if you ever recorded a multi-channel EEG, you know that you have, as you just said, time series. And that's very important in EEG, the evolvement over time, the connections over time within one channel, but also the connections over time within several channels. And if you plot a multi-channel EEG, and in former times they did that on those paper machines that were rolling out the EEG. Nowadays we have our tables. And if you look at an EEG that way, then you see that the EEG is nothing else than a two-dimensional matrix. And a two-dimensional matrix can be handled just as a picture, because a picture is nothing else as a two-dimensional matrix of numbers corresponding to colors. So once I got that connection, I wondered myself, well, can we use the EEG and deep learning together as a highly sophisticated analysis method? And then I thought, okay, I have an EEG of maybe resting EEG of 60 seconds or even longer, 10 minutes whatsoever. So this is much too large, as it is a picture. It's more than a movie. And then I thought, okay, what is a movie? A movie are several pictures, each after the other. So the EEG can be segmented into one picture following after the other. And if you do it that way, you're going to create lots and lots, hundreds and thousands of pictures from just one resting state EEG.
Wow.
And as everyone knows from the media, for deep learning, you need lots and lots of data. And maybe this is why people don't think of EEG data and deep learning. They say, okay, I have to record hundreds and thousands of people to do deep learning. No, that's not the case. EEG is so rich of data, that's such a high amount of data that you can get from EEG, especially high sampling rate recording EEG, that deep learning is perfect for EEG. So then you cut your EEG into segments of, for example, 1 second, 32 channels or 19 channels or 64 channels, and do that with a sampling rate of 500 hertz. You get a pretty nice picture that is the same as your resolution of your screen. So a nice picture. Then you stack them together, and then you have several subjects and you feed the machine with that. And we did that 5 years ago, and we started with a very not easy task, because we were asking ourselves, okay, does it really work? Can we use EEG in deep learning? And we were questioning ourselves and asking, okay, what is a so-called ground truth scenario? So where a scenario where we know there is some truth that is really there, and we can prove it and try if the machine can learn that. And we decided, okay, it's very hard in EEG. If you say that subject maybe has, I don't know, depression, this is not depressed, then there's always one expert saying, no, this is not depression, this is something else. So we needed to break it down to something more simple. And we got it in the human, in the sex, being male or being female. It doesn't matter which orientation you have, but the natural given sex is there. So we can try, or we try to let the machines learn, the deep learning machine learn, if a subject is male or female. And we had 1,300 EEGs, and we separated them into training and a test set. And this is one very, very important point. Maybe we get to that later. In deep learning, you have to always, and this is a major point, you have to separate your data into a test set and a training set. And if you have a test set, let it be 10 to 25% of your data. Try, and you have different labels. Try to make them equal, like 50% X and 50% Z in your labels, and put that training set aside. Put it in the closet and leave it there. Don't touch it. And then you have a training set, and you can do a lot of stuff with that. Try different models, reshape your network, stuff like that. And only in the end, when you're confident with your models, and if you really have validated your data within your training data, then take the data out of your hidden treasure box and then apply the network again and see if it worked. So we did that with 1,000 EEGs and then tested on 300 EEGs, and the machine was really able to differentiate 84% correctly as being male and female. And now one might say, okay, for a human being, it's very easy looking at the male or female. Maybe we have like 95% accuracy. However, if you ask any EEG expert to differentiate by looking at an EEG, if it's male or female, they all say, well,
it can't.
No clue. It's impossible. So this was the proof that EEG and deep learning really worked.
Wow.
And this really pushed us toward using that for other tasks on the EEG scene. So that was the beginning. And then, of course, you asked for the paper. We just did the review. Well, maybe I have to explain that, or as I already said, I work in a hospital as a psychiatrist. And we were really keen on getting results that can be used for the clinics, that can make a benefit for the patients. So we try to look in the clinical literature using EEG and deep learning, so not the wide range of BCI and stuff like that. However, the methods are very similar. And we were very astonished that only a very small portion of the published EEG papers used this great technique. So there were just around 30 to 40 really good designed papers and studies that used the EEG deep learning with psychiatric disorders. And we looked at that, and we found some, it's not mistakes, that's wrong, because I think all those boys and girls, men and female, did great job using EEG and deep learning. However, they did some things wrong, we think, and maybe it's worth mentioning, because one of the most important points if you apply deep learning and EEG is not only, as I said, separate training and test set, but that you put distinct subjects into your training and test set. I want to explain why. The reason is the EEG is one of the most heritable things we have. It's even more unique to yourself as your eyes, color, or your hair, or your skin, or everything. So the EEG really is an expression of your genes. And this means that there is a very high inter-subject variability, but within a subject, it is very similar. If you record it now, or in a week, or in 2 weeks, or in a year, your EEG has a unique, like just like your fingerprint.
Oh,
and this means, yeah, it is like that.
I'm getting
People don't realize. And now
Yeah, because the reason I'm getting excited right now is that I literally last year I made a video and I said just that. And there were people who laughed at me. They're like, what do you mean EEG is a fingerprint? I said, look, if your thoughts are the same routine over and over, and it's like that makes you, and that's your consciousness, would it be hard to think that, you know, your EEG, because that is emanating from a thought, would be also a fingerprint. So sorry to interrupt you. I'm just getting too excited right now. Please go on.
No, but that's a very good metaphor you made. Like you think all the time within this
Yes.
brain, and the traces are there, and they cannot be erased. So what we see in the EEG is the traces that are being left.
You have actually identified also that there is a same pattern, like a fingerprint for each of your subjects.
Yeah, there is. I mean, it's hard to extract it, but what the machine does, and this is very important, if you put segments or single epochs of the EEG in the training and the test set, and let's stick with the example of males and females, and the machine knows, oh, this is Mr. XY, and you have some segments in the training set. So he remembers, oh, there's Mr. XY. He has very high alpha waves in the back. I don't know, just something like that. And he knows that's Mr. X, and Mr. X is a male. And then he discovers in the test set, oh, this is Mr. X. So he didn't discover that it's a male, because male is a much more broad definition. But he discovered Mr. X in the test and says, oh, I remember Mr. X, he's a male. So if you don't separate the subjects in a test and training set when making classification tasks between subjects, then the machine learns with a high accuracy, very high accuracy, the different subjects, and it will realize where they are and put the right label on. And this is why in most, or in 1/3 or even more of the papers, the people did not separate the subjects for training and test set. They used the first 10 seconds for training, and then for testing, and then for training. And then they get accuracies of like 98% or 95% for labeling, which cannot be that accurate. Because in psychiatry, like being depressed or not depressed, it's a soft boundary. It's not a hard, like breaking your arm. It's not true or not true. It's some kind of shady ground. So there cannot be an accuracy of 99%. That's impossible. But they train their machines and they get accuracy that's just beyond. So this is a very big mistake. And the problem with the future is, if people now announce, well, we make deep learning, we get accuracies of like 95, 98%, the people will trust it. And then they will realize, okay, but when I apply it to new data from different subjects, it doesn't work. It doesn't even get like 50 or 55% of accuracy. And then the people won't believe anymore in this technique. So it's very important that we are very aware of those mistakes that we can make. And I think this is very important.
And this is what you meant with the pitfall that you had identified, right?
This is the most important.
When I read your paper, I read the whole paper. I mean, obviously, I'm not an MD, so it went over my head. But the parts where you're talking about, so I know EEG, but again, at my level. And so that is what I was trying to understand. What does he mean by pitfall again? So that's what you mean, to separate the two. Now, yes. I have a question. Obviously, you have access to a lab with fundings, etc. What advice do you have for young minds who are now watching and they are, very excited and want to do this, that maybe don't have access to a lab? And before you share your advice with us, I just want to share with you that that's one of the reasons I got very excited about computational neuroscience. And I took my first course last year at Neuromatch Academy, was because essentially what I understood was that even underprivileged young scientists could now embark on this journey, and they don't need this, when I was at Stanford, like at the fMRI machine, it was like for an hour, I think the professor had to pay like $1,000, and we used to go at midnight so that we would get half a price up. So I would actually drive all like 2 hours to 1 hour to the university lab, and at midnight, because he said, hey, I want to, like, instead of two subjects, I want to run 4 subjects with the same price because they were cheaper. So they're very expensive, even for, you know, Stanford professors. So for us, like people who are not, you know, underprivileged, we don't have much money. What advice do you have? So for example, Python is free, you know, and then there is like commercialized EEG, like Emotive Epoch that I use. Or anything, any advice you have, please.
I think it's very good that you get to that point, and it's very important to get as many people involved in that research, because I think many minds can do a lot of things, and the more they get involved, the better. And you're right. The good thing about EEG now is that on the one side, there are now freely available databases. So for getting data, clinical or non-clinical, you can really use free databases. There are some problems with standardization, stuff like that, but for a starting point, that's a good one. Just like 3 days ago in a cooperation, or I'm cooperating with the brain clinics in Nijmegen in Holland, and they just made available via a Nature Methods paper, a very large database on EEG on patients treated with transcranial magnetic stimulation, TMS therapy. It's a data set, I think it's over 1,000 subjects. Don't get me wrong, I don't have the real numbers, I have to look it up. It's just very fresh on the web, and everyone can access it, ask them, say I want to do some research, and I think they will be open to share that. So that there are many resources, so from the Max Planck Institute in Germany. So it's a good starting point for, you don't have, as you said, drive to the lab in the night and pay lots of money to get data, but there are lots of data out there, and for training, for getting a feeling for the things, you can use the data sets, and I think you can even discover new things in those data sets. It's not that they're like, everything has been done on that. That's not true. Most people, as I said, they get funding in academia, and the problem with academia is they live on funding. So they have a funding, they do a great research, do a study, have the data, and no one there who's going to analyze the data. So they sit on like piles of data. And I think making sense and making use of this data is important. So you can start with data that's already there, that's freely available. The second thing is that nowadays I see emerging devices that are commercially available, that are not too expensive. In the beginning, I had my problems with the quality you get from those devices, but it's getting better all the time, and it's really evolving very fast. All I want to say to the young researchers who are interested, like just test those sets. For just a very simple example for testing an EEG data set, EEG device, is put it on your head, and maybe it'll just got like 8 electrodes or 10 electrodes, and just try to make the open eyes and close eyes scenario, the Berger maneuver, who discovered the EEG. If you're going to see these alpha waves in the back or not, if you can see them, okay, it seems to work. You don't know much about the quality, but it's just a very quick check of if it's working. Be aware, after Hans Berger discovered that, I think in Stanford, I'm not sure if it was Stanford or Massachusetts, I don't know, but they tried to test the Berger maneuver in the 40s, and they didn't see anything. They tested 1 subject, 2 subject, 3 subject, and they said, oh, something's wrong. Mr. Berger said there is an alpha rhythm, but there was not. And then they discovered that with the 5th person, they saw the alpha rhythm, and they really had 4 subjects before which didn't express the alpha rhythm. So some people just don't have it. So if you don't see it, maybe the device is wrong, or you have a subject without an alpha rhythm. So, and that's some kind of tricky. If you want to dive into those history of EEG, also the Brain Clinics has a great resource on the website with videos of the first pioneers of the EEG. That's really great, just by the way. And then you were asking okay, now you have the data, your own device or your data set, what do you do then? And as you said, many things in Python can be done using Matlab. Matlab costs little money, but not little, a lot of money. But there's this Eeg Lab that can be used via Matlab, and this is free for usage. That's a great resource. And there's Python, for example, just giving examples and not preferring something, just giving examples. You can use the MNE framework, which is free, which has a lot of resources and functions you can use, and it's open, you can change it, you can check it. And so within this Python frameworks, it's really great to work. And then using deep learning, you can use like something like Keras and TensorFlow. So TensorFlow is like the the framework that does the work. Keras is a wrapper that makes it easy for you to do the programming, just a few lines, and you have a network, like 50 lines, you have a deep learning like network. And then, of course, you need the hardware. And most people say, well, now Corona crisis, the chips are very sparse and they get expensive. And how do I get a good GPU, graphical processing unit for deep learning? Well, there are other resources that are for free. Just to give an example, the collaboration lab from Google, Colab.
Yes.
It's a free environment. You can just need your email, log in, load up your data, be aware that it's anonymized, of course, load up the data, and you can use for free GPUs, and they're as fast as mine at home. So it's really a great resource to do that. Yeah. And you can do that from any laptop without much power. Just log on the server and do your research. And I think having all this combined, having data, having free software, having free hardware, and anyone everywhere in the world can do that. You just need the ideas and need to dive into the topic.
Perfect. I love the fact that you also mentioned Eeg Lab on Matlab. That's actually what I did for my studies. And then Emotive Epoch. It has 14 sensors, but I did a lot of research before that. So even MIT and Stanford have used them in there. So to your point, it's not your traditional full-on EEG, but it does the job. And so I was able to myself actually build a lab for under $1,000. So that's I think that's brilliant. And to your point, yeah, Python is free. Those notebooks for Python is also free. So yeah, I think that definitely, I think we're living in a very exciting time that we're not as bounded as scientists in the past. I mean, you have, to your point, all these amazing stuff, both hardware and software, much cheaper than they were before. So thank you so much. This was great. I learned personally so much from you. If our viewers want to learn more about your work, where can they best find you? Are you on social media, or where is it best?
Yeah. So you can follow me. I'm on, of course, on the social medias. If you have a question, you can send me a question on sebastian.olbrich@deepsci.com. Maybe that's too late now to share the screen, but yeah, you can find me there, DeepSci. And DeepSci is also a company I founded like 1 year ago. You can find it on net, deepsci.io. So this is the non-academic part of my work. You can follow us there, and also we are on Twitter and on LinkedIn. You can also find us. So if you have any questions on that, or if you have any comment on what we said today, of course, you can just send me a message, or send a message to you, Nilo. Maybe you forward that, and it's going to be great. And as you said, there are many EEG researchers in the world, but they are like everywhere isolated, working on their own, more or less on their own. I think we need to get more connected, and it's like connecting the neurons, and then we will have a great network that works together.
Yeah, absolutely. If you have time, you can email me your contact information, and I can put it in the description of the video. Or if you want to put it in the comment, I can pin it on the video, so it shows up in the first, so that anybody who wants to reach out to you, they have your information, both on Twitter, all of that. So that would be easier for them. They can just click and get to you directly. Thank you so much. This was amazing. You have no idea how excited I am. And I know that your time is very precious, but hopefully we can stay in touch. And thank you so much again. This was amazing.
Yeah, I enjoyed it also. Thank you very much. And
thank you so much. Have a great day. Yes.
Bye-bye.
Bye. Bye. Okay, guys, I hope you are as excited as I was. It was just amazing the way he talked about everything. But anyways, as I was saying, I think this is a very interesting time that we live in. I think that we have so much opportunities, and a lot of us can actually we can come from underprivileged background, like me, where I came from, and still kind of make it happen. So if you're interested in either learning more about science or anything like that, definitely, I think these type of people like Dr. Olbrich is definitely a person to follow. Hope you enjoyed it. I'll see you guys next time. Bye.